Hello, welcome to Astronautics for Exploit. I am Dr. Ayenshola Ogundele, and I'll be presenting History of Manned Suborbital Spaceflight. The overview of my presentation is as follows. First, orbital and suborbital flights, manned suborbital spaceflights, Mercury-Redstone Spaceflights, X-15 spaceflights, Soyuz 18A, the April 5 Anomaly of 1975, and SpaceShipOne Spaceflights. The development of manned suborbital commercial space vehicles is rapidly occurring, and flight testing is being followed by the operational flights. A trajectory is a path that rocket or spaceship takes. For one to be in orbit, one has to be going around the planet continually, moving fast enough that one will keep cycling it forever. Suborbital flight. On the other hand, if one plugs off and makes a huge arc, eventually falling back to the Earth, one never made it into orbit. The flight is referred to as being suborbital. No matter how far off into space one goes, if one's path causes one to fall back down to the Earth, then it is a suborbital flight. Presently, there are several companies who are trying hard to make space tourism a reality, and they are doing this by designing suborbital trajectories and developing reusable launch vehicles to achieve this aim. First orbital and suborbital flights. First persons in space. The first person on an orbital flight, which took place on April 1961, was Yuri Gagarin. First suborbital flight. The first person on a suborbital flight and second person to travel to space on May 5, 1961 was American Alan Shepard in the first of the Project Mercury rockets, launched less than a month later. After Alan Shepard, all future missions were planned to be orbital. This picture shows Yuri Gagarin during his epochal 108-minute orbital flight and Alan Shepard inside of Freedom 7 before its launch on May 5, 1961. Manned suborbital spaceflights above Karman line. The history of manned suborbital spaceflights is as follows. Mercury-Redstone Spaceflights 3 and 4, X-15 Spaceflights 90 and 91, Soyuz 18A, the April 5 Anomaly of 1975, and SpaceShipOne Spaceflights 15P, 16P, and 17P. This picture shows Neil Armstrong with the X-15 on the dry lake bed at Edwards Air Force Base in California. The list of manned suborbital spaceflights above 100 kilometers in altitude is given here. 1961-05-05 Mission Mercury-Redstone 3. Crew Alan Shepard, United States. This was the first crewed suborbital spaceflight and first American in space. 1961-07-21 Mercury-Redstone 4. Crew Fergie Grissom, U.S. Second crewed suborbital spaceflight, second American in space. 1963-07-19 X-15 Flight 90, Joseph A. Walker as the crew, U.S., and this was the first winged craft in space. 1963-08-22 X-15 Flight 91, Joseph A. Walker, the crew, then U.S. First person and spacecraft to make 2 flights into space. 1975-04-05 Soyuz 18A. The crew members are Vasily Lazarev, Oleg Makarov, Soviet Union. Failed orbital launch, and it was aborted after malfunction during stage separation. 2004-06-21 SpaceShipOne Flight 15P. Mike Murphy was the crew, US, and this was the first commercial spaceflight. 2004 0929 SpaceShipOne Flight 16P, Mike Murphy, US. And finally, 2004 1004 SpaceShipOne Flight 17P, Brian Binning, US. Second S-Prime flight clinching award. Mercury-Redstone Spaceflights 3 and 4. The objective of Mercury-Redstone flights of 1961 are to put an astronaut into orbit around the Earth and return him safely, and to demonstrate ability to withstand the IG forces of launch and atmospheric re-entry. This picture shows the flight of Freedom 7, the Mercury rocket piloted by Alan Shepard. Mercury-Redstone 3 or Freedom 7 was the first United States human space flight, which took place on May 5, 1961, and was piloted by astronaut Alan Shepard. It was the first crewed flight of Project Mercury and the 15-minute suborbital flight. Alan Shepard's spacecraft reached an altitude of 101.2 nautical miles and traveled a downrange distance of 263.1 nautical miles. This picture shows Alan Shepard on the deck of the aircraft carrier USS Lake Champlain after recovery of Freedom 7. Activities during the mission. During the flight, Shepard observed the Earth and tested the capsule's attitude control system, turning the capsule around to face its blunt heat shield forward for atmospheric re-entry. He also tested the retro rockets, which will return later missions from orbit, though the capsule did not have enough energy in order to remain in orbit. Activities during the mission. Also, after re-entry, the capsule landed by parachute on the North Atlantic Ocean off the Bahamas. NASA research mathematician Katherine Johnson did trajectory analysis for the missions, America's first human spaceflight. This picture shows liftoff of Alan Shepard's MR3, Freedom 7 on May 5, 1961. Mercury-Redstone Suborbital Flight Trajectory. The spacecraft traveled along an ascending parabolic flight path, having a high point of about 115 nautical miles and a total range of roughly 300 nautical miles. Total flight time was about 15 minutes. The Mercury spacecraft was designed to accommodate a single crew member with a length of 9.5 feet and a base diameter of 6.5 feet. This picture shows first U.S. manned suborbital spaceflight trajectory. The flight description. On May 5, 1961, astronaut Alan Shepard had a view of Earth from the Freedom 7 Mercury capsule on his historic making suborbital flight. The 15-minute flight lifted him to an altitude of over 160 miles and a maximum speed of 5,134 miles per hour. During the flight, Shepard reported seeing the outlines of the west coast of Florida and the Gulf of Mexico, along with Florida's Lake Okeechobee. This picture shows Alan B. Shepard's view of Earth on May 5, 1961. Alan Shepard's flight trajectory. Normal sequence of events for Mercury-Redstone flight is also shown in this picture. Alan Shepard's flight sequence. At 000, there was liftoff. Mercury-Redstone liftoff on board clock starts. At 0016, pitch program. Redstone pitches over 3 degrees per second, from 90 degrees to 45 degrees. At 40 seconds, end pitch program. Redstone reaches 45 degree pitch. 124, maximum Q. Maximum dynamic pressure approximately of 575 pounds-force per feet squared. Then 220 Beco, Redstone engine shutdown, booster engine cutoff, and velocity of 5,200 miles per hour reached. At 2:22 there was tower jettison, escape tower jettison, and no longer needed. Spacecraft separation took place at 2:24. Postgre rocket fired for 1 second, giving 15 feet per second separation. 2:35 there was turnaround maneuver. Spacecraft system rotates and the space by 180 degrees to each sheet forward altitude. There was manual control at 2:35. Manual controls unlocked and pilot test all axes. Retro altitude maneuver occurred at 4:44. The ASCS orients spacecraft to 34 degrees nose down pitch, 0 degrees roll, 0 degrees yaw. At 5 minutes, apogee of about 115 miles was reached. At 150 miles, downgrade from launch site. Retrofire occurs at 5:15. 3 retro rockets fire for 10 seconds each. They are started at about 5-second intervals. Firing overlaps. 550 feet per second is taken off forward velocity. At 5:55, there was retraction of periscope. Periscope is automatically retracted in preparation for re-entry. Retropack jettison occurred at 6:15. 1 minute after retrofire, retropack is jettisoned, leaving 8 shield clear. At 7:15, there was a 0.05 G maneuver. ASCS detects beginning of re-entry and rolls spacecraft at 10 degrees per second so as to stabilize spacecraft during re-entry. At 9 minutes 38 seconds, drogue parachute deploy. Drogue parachute deployed at 22,000 feet, that is about 6.7 kilometers, slowing descent to 365 feet per second and stabilizing spacecraft. At 9:45, there was snorkel deployment. Fresh air snorkel deploys at 20,000 feet, switches to emergency oxygen rate to cool cabin. At 10:15, there was main parachute deployment. Main parachute deploys at 10,000 feet, that is about 3 kilometers, and descent rate slows to 30 feet per second. Landing bag deployment occurred at 10 minutes 20 seconds. Landing bag deploys, dropping each sheet down to 4 feet, that is 1.2 meters. At 10:20, remaining hydrogen peroxide fuel automatically dumped. And there was splashdown at 15:22. Spacecraft lands in water about 300 miles, that is 480 kilometers, downrange from launch site. And at 15:30, rescue aids deployed. Rescue aid package deployed. The package includes green dye marker, recovery radio beacon, and WIP antenna. Second U.S. woman spaceflight, Mercury-Redstone 4, was the second U.S. woman suborbital spaceflight, which occurred on July 21, 1961. The suborbital project Mercury flight was launched with a Mercury-Redstone launch vehicle. The spacecraft, Mercury capsule number 11, nicknamed the Liberty Bell 7, was piloted by astronaut Fiji Grissom. This picture shows astronaut Virgie Grissom being assisted by astronaut John Glenn. Mercury-Redstone 4 mission activities. The spaceflight lasted 15 minutes 30 seconds, reached an altitude of more than 102.8 nautical miles, and flew 262.5 nautical miles, that is about 486.2 kilometers downrange, landing in the Atlantic Ocean. This picture shows astronaut Vijay Grissom. Mission activities. The flight went as expected until just after splashdown, when the arch cover decided to release explosively in the event of an emergency accidentally blew. Grissom was at risk of drowning but was recovered safely. The spacecraft sank into the Atlantic and was not recovered until 1999. X-15 spaceflights. X-15 spaceflight of 1963 was the first of two X-15 missions that passed the 100 km high Karman line, the FAI definition of space. It was the suborbital spaceflights which used the famous X-15 rocket plane. A pilot took active control of all aspects of the flight. X-15 aircraft was used as testbeds for a wide variety of experimental packages. This picture shows a North American X-15 which made two suborbital flights in July and August, becoming the first reusable spacecraft. X-15 spaceflight from 1963. X-15 Flight 90 was a research flight conducted by NASA and the U.S. Air Force in 1963. Both X-15 Flight 90 and 91 missions achieved suborbital spaceflight and passed the 100 km high Karman line, the FAI definition of space, and they were flown by Joseph A. Walker. This picture shows Joe Walker, who flew X-15 Flight 90 and X-15 Flight 91. The X-15 research aircraft was developed to provide in-flight information and data on aerodynamics, structures, flight controls, and the physiological aspects of high-speed, high-altitude flight. The aircraft was used as a testbed to carry out various scientific experiments beyond the Earth's atmosphere on a repeated basis. This picture shows X-15 drops away from the B-52 and the rocket ignited to start its mission. X-15 flight trajectory. For flight in the dense air of the usable atmosphere, the X-15 used conventional aerodynamic controls, such as ruders on the vertical stabilizers, so as to control yaw, and movable horizontal stabilizers to control pitch when moving in synchronization, or row when moved differentially. The typical flight research paths flown by the X-15 diagram is shown in this picture. For flight in the thin air outside of the appreciable Earth's atmosphere, the X-15 used a reaction control system. Hydrogen peroxide thrust rockets located on the nose of the aircraft provided pitch and yaw control. Those on the wings controlled row. This picture shows profile and details of a flight in which the X-15 achieved its design goals in speed and altitude and came very close to that point in structural temperature. There was complete pullout at 65,000 feet. At 130,000 feet, re-entry starts, which signified the end of 0G. Then there was burnout at 160,000 feet, beginning of 0G speed. Then there was the launch from B-52 at 45,000 feet. Because of the large fuel consumption, the X-15 was air-launched from a B-15 aircraft at 45,000 feet and a speed of about 500 miles per hour. Depending on the mission, the rocket engine provided thrust for the first 80 to 120 seconds of flight in order to accelerate to anywhere between Mach 2 and Mach 6, while climbing as high as 350,000 feet. Execute a successful hypersonic re-entry through Earth's atmosphere. This picture shows artistic representation of X-15 flights along the high range. The yellow band signifies lower altitude speed runs, and the red band the high altitude suborbital flights. The remainder of the normal 10 to 11 minutes, flight was powerless and ended with a glide back to a 200 miles per hour on power landing on the dry lake bed. Soyuz 18A mission, which is referred to as the April 5 Anomaly of 1975. The Soyuz 18 mission purpose were to perform a 2-day orbital flight test of the upgraded Soyuz 7KT ferry to check out the modifications made after the loss of 3 cosmonauts at the end of the Soyuz 11 mission to the Soviet Union's first space station, SpaceShipOne in June 1971. This picture shows the astronauts Vasily Lazarev and Oleg Makarov. Soyuz 18A mission was not originally planned to be a suborbital flight, but was the first ever in-flight launch abort of a crewed spaceflight on April 5, 1975, on what was supposed to be the Soviet Union Soyuz 18 mission. The crew, veteran cosmonauts Vasily Lazarev as the commander and Oleg Makarov as the flight engineer. This picture shows a Russian diagram of the various Soyuz launch abort options during its ascent. SpaceShipOne Spaceflights. The White Knight and SpaceShipOne flight of 2004 was the first private suborbital spaceflight which was designed to carry a pilot and up to 2 passengers to an altitude of up to 112 kilometers. SpaceShipOne was launched by Mojev Aerospace Ventures on June 21, 2004, and this makes it the first private suborbital human spaceflight. This picture shows White Knight carrying SpaceShipOne during a captive flight test. Trajectory analysis. After being dropped at an altitude of about 15 kilometers from a specially built Model 318 carrier aircraft, which is known as White Knight, SpaceShipOne climbed steeply under the power of an 88 kilonewton hybrid rocket motor. The hybrid rocket motor burned for up to 87 seconds, but unlike the conventional solid rockets, could be shut down at any point by cutting off the oxidizer supply in order to meet mission requirements or abort its flight if necessary. This picture shows dropping of SpaceShipOne from White Knight. After reaching apogee, SpaceShipOne used a unique feathering re-entry system, where the rear half of its wing, along with its twin tail booms, will pivot upward on an hinge so as to provide an aerodynamically stable configuration. This picture shows flight profile for SpaceShipOne. The high drag mode used during its steep descent limited eating during re-entry, where deceleration loads reached as high as 5G. Once the craft had descended to an altitude of 10 to 20 kilometers, the wing on SpaceShipOne moved back into its low drag configuration so that it could glide to a landing on a runway about 20 minutes or so after. This picture shows White Knight and SpaceShipOne flight path. For more information, contact Astronautics for Exploit. Thank you.